All right, thank you very much. It is a great honor and a humbling experience to be asked to talk in this plenary. Maybe such a great honor for some of us. You'll notice that two of the speakers went to great lengths to get out of it. But I'm fortunate because I have the easiest topic here to talk about fire in a warming climate, talk about climate change. And I've been thinking about how to discuss this because I think that climate change for many of us, some people are climate scientists, some people are doing research directly in climate and forest and fire areas, but for many people and for a lot of people in management, it's a puzzling, annoying, complicated, uncertain kind of a future. And basically that is what it is, puzzling, annoying, and uncertain. But I'm going to try to bring up a few things that might be useful for us to think about. I was particularly struck in Tessa's presentation earlier this morning where she introduced a lot of things and she just said, you know, here's something, why don't we just think about this? Why don't we just look at this and mull it over? And so I've noticed people taking notes during some of these presentations. So I would not suggest writing down what the temperature is going to be in the year 2080 or something like that. But maybe note down some questions or some ideas, and particularly for managers with so many scientists here that are working on these issues, this might be an opportunity for interchange. Okay, so Bill brought up earlier the complexity of terminology and the way that that needs to be discussed right now. Here was one solution to that problem, a very straightforward, extremely effective advertising message that practically everyone in the United States can complete this sentence. The figure on the right, on the other hand, is an extract from the Coconino National Forest webpage talking about managed wildfire and linking to 10 other pages and a whole bunch of submenus and so on discussing why it's so complicated. But everybody here in this room, as the speakers have been talking earlier this morning and based on all of your work, understand the complicated message. And you're able to simultaneously hold multiple different ideas in mind as we try to move forward. And I think climate change is going to call on us to practice that kind of skill much more in the future. So I'm going to talk a bit about that complexity, talk about some tools, and these tools focus on some projects that our group is working with, not because they're right or because they're the best, they're just ones that I happen to know about. But here in this conference and at other meetings, there are a variety of approaches to trying to understand these issues for the future. And I want to finish with a quick look to the south and then talk briefly about some implications. So this is from the National Assessment of Climate Change Impacts in the United States. You all have seen these kinds of maps colored red. You've seen these lines that move upwards as we go through the 21st century. Basically, the lines that are shown here show a kind of moderate climate change scenario of a few degrees Fahrenheit by the end of the century to a much larger change associated with increased emissions of greenhouse gases. And one of the main things that I think sets the stage for the uncertainty for all of us and for the world scientists and world leaders that are trying to deal with these issues is that we don't know which of these paths humanity will follow. Our problem is not so much that we can't develop a good model to say how energy is distributed in the atmosphere. That's a problem, it's a challenge. But the much bigger problem is just how much more greenhouse gases are we going to be emitting over the course of the century. That's the real uncertainty. To try to get a handle in making a comparison, I borrowed or stole from my colleague Tom Cole the idea of showing pictures of some places that represent current conditions at 7,000 feet, Ponderosa Pine Forest in Flagstaff, Arizona. Well, a about 2.5 degree temperature increase would take you to Gallup, New Mexico, and about a 500-foot decline in elevation. An 8 or so increase in average temperature takes you to Prescott, Arizona, and quite a different kind of ecotone and vegetation community. So as climate shifts, vegetation shifts also. And it's disturbances like fire, like bark beetle outbreaks, like severe drought episodes that are the mechanisms of these shifts, the things that cause the shifts to happen in pulses. This is why it's really bad to look at those graphs that show a gradual increase in temperature and think that everything's going to change gradually and incrementally. Instead, it's through large fire events like the Las Conchas fire that we talked about a little bit ago that changes occur. So scenarios of the future need to be able to intertwine climate, vegetation, and fire. And many, many people are working on that. the kinds of conclusions that we reach are really diverse. So the papers shown on the right-hand side here range from massive conifer mortality in a very short time period across the west and the southwest, to predictions that forests, especially the mature trees in forests, may be able to hang on in something quite close to their current conditions well to the end of the century. We don't know which of these predictions is right. One of the reasons they differ is because they take different approaches. They might look at stand dynamics, at statistical models of relationships with climate, at ecophysiological responses of trees. So all these kinds of factors, we need to be working together and trying to understand and come up with better solutions. So we'll look at one example of some tools that can be used in this way on tribal and public lands. Excuse me, I went too fast on that because I wanted to call your attention to one tool that could certainly be used more, and possibly our next speaker might touch on this a bit. The traditional ecological knowledge of people who have inhabited landscapes for long periods of time and have had relationships with fire that are very deep. This example comes from Canada, where social science researchers working with the tribal community are developing vocabulary, a dictionary of all the different ways that fire is used in that environment. Tribal and public lands make up most of the West, as you know. The Southwest in particular is the place where we kind of seem to have the closest balance of tribal lands and public lands in terms of area. And it was on tribal lands that some of the early reintroduction of fire as an ecological process occurred. This is from Biswell's book, 1973. He's pointing out Harold Weaver, who looks a little concerned because he's surrounded by these fuel ladders. Weaver and others in tribal communities and in the Indian Service and in the BIA initiated a lot of prescribed burning in central Arizona and in the Southwest. And they also published, for instance, Weaver's 1951 paper. There's a clip from that here. If you have, many people here have seen this a million times, but for anyone who hasn't, you can read it, and it's basically just like reading the newspaper headlines right now, or a description of the Forest Restoration Initiative. It's not that these problems were not identified, it's that we have not quite acted for some of the reasons that Kip brought up a few minutes ago. I wanted to comment on one type of a success story at a scale a little bit different from the one that we're going to hear about in a few minutes, but this is from the Hualapai tribe in northwestern Arizona, known as the People of the Tall Pines, who resumed burning in conjunction with support from the BIA, this kind of managerial support that's so important in getting things done, around 1960, and have a forest managed with uneven age silviculture. These are some scenes from that area in the northwestern part of the Grand Canyon region. This is work by Amanda Stan and others reconstructing the fire history there. So this is a fire chart like the one that we saw earlier today. The basic point is that on the left side where it's shaded in, that's the historic fire regime, which was interrupted after about 1860, 1870 in this case, and had a long period without any fires, but then beginning in 1960, beginning 90 years later, began to resume through burning and through wildfires that burned up there. And so the current fire pattern is statistically indistinguishable from the pre-1870 fire pattern. So this is a kind of temporal, an example in time of beginning to restore fire regimes. And many of you are familiar with this kind of example from places like Grand Canyon National Park or the Gila Wilderness or the Saguaro National Park down here in Tucson. This is an example on native lands. In addition, through uneven age management of the forest, the diameter distribution of the ponderosa forest is more similar to the natural forest rather than the strong reverse J shape, the very dense forest dominated by young trees that we see in FIA data from the whole state of Arizona. Amanda's project also included outreach activities with kids from the community shown here, taken out in the forest, looking at tree rings, looking at how climate affects tree rings, talking about these issues in association with their lands. The tool that I want to focus on for a little bit is the Climate Forest Vegetation Simulator. So FVS is the most widely used model in the US. It's supported through documentation, through technical support, websites. Most people in federal agencies have access to and use FVS. Nick Kirkston and Jerry Rayfelt modified it to take climate change effects into account. FVS is a statistical model. It doesn't model processes associated with climate. But by putting on a modifier of species viability, they allow it to adjust. This isn't a perfect fix or an ideal model solution, but it's something that anyone today in the management community can make use of and begin to get some idea of how climate change may affect their forests and fuels and fires. So climate FES is based on this species viability score, which adjusts the existing models of growth, mortality, and allows you to auto-establish or bring in regeneration. So if you understand that currently is dominated by ponderosa pine, perhaps in 40 or 60 years, pinon or juniper might have an advantage in establishing in that stand. These kind of data come from analysis of bioclimatic envelope. So basically just looking at the very large amount of data that we have from FIA data sets of temperature, precipitation, and where species are found or not found across the western United States. This allows you to build very precise models because we have many thousands of these data points. Of course, there are many disadvantages to this approach as well. Just because the climate may be right for something to exist doesn't mean it will be able to make its way there or become established. And there are many other modeling approaches besides this. But this is the approach that was taken in climate FES. The scenarios for climate in this setup and in many of the studies that people have done are international scenarios. This is a really powerful thing because through the Intergovernmental Panel on Climate Change, the world's climate scientists come together and develop models, compare models, make multiple models available for download on public websites with transparent methodologies. And that means that we can sit in Flagstaff, Arizona, and download data and make comparisons with climate scenarios that are the same that people are using in Australia or in Spain or Mexico or wherever. In terms of management scenarios, this is where FES does have a strength because it's designed for management. You can cut trees in certain ways. You can have all sorts of very detailed kinds of prescriptions and ideas that you can test. When looking at the species viability score, the projections across this century, what we have here, this is work from Kristen Shive, and she's mapping on White Mountain Apache lands the changes in viability under a severe climate change scenario on top and a moderate climate change scenario on the bottom. Under the severe change, it's the pinon and the juniper species that end up at the end of this century being viable in the sites currently dominated by ponderosa pine. On the bottom graph, the current conifers drop a lot, but they still remain above a threshold that's considered to be allowing them to perpetuate themselves in that stand. And when we look at individual species performance, here we have ponderosa pine in the top graph. The solid line is with no climate change. So basically the point is that every other scenario of climate change for this ponderosa pine, this is on the Apache Sitgreaves National Forest, worked by Alicia Espaleta. All the other climate scenarios are worse for ponderosa. But under moderate change, it still remains a strong, dominant species. Under severe climate change, it disappears. If you look at the bottom graph with Gamble Oak, again, the solid line is no climate change. Now there are moderate climate change scenarios that favor Gamble Oak. So this suggests that things that we have been accustomed to see as a community, like a pine oak community or a mixed conifer community, are likely to separate as climate change, as warming continues, warming and other factors like disturbance. There are many ecosystem services that one can look at with this kind of analysis. This is a quick snapshot of carbon. So we see under no climate change, pretty high above ground carbon at the end of 100 years of simulation. These are sites that were treated or not treated before the Rodeo Chetaskai fire of 2002. Under moderate climate change, we lose about 1/5 of that carbon. Under severe climate change, where the dominant species shift entirely to shrubs or grass, we lose 95% of that carbon. And the last one from Climate FES is a comparison of multiple different treatment regimes against some sort of a target. Tessa presented earlier some work by Dave Huffman where they looked at ecological restoration ranges of variability and then assessed how wildland fires met or did not meet making changes associated with falling within that range of variability. And this is the same kind of idea applied to White Mountain Apache tribal lands, where the conclusion was that uneven age management practiced there with fire use through prescribed fire or other kinds of fire use was consistent with resilience to the rodeo Chetasky fire. That was demonstrated in that fire. And that those kinds of forest conditions and that management approach is, at least appears to be consistent with maintaining an open forest with frequent burning, at least under moderate climate change conditions through this century. So it's in this way that these kinds of tools can begin to give us a handle and allow us to begin to take climate change effects into account. With a different approach, this is work by Kristen Honig, who asked whether future fire weather, we currently assess the severity of weather conditions using percentiles, using something like Fire Family Plus, where we will say that a certain wind speed is the 95th percentile, the 97th percentile, or so on. Because we recognize in the model, if we just crank the wind speed up to some super high number, we can always get a crown fire, but is that realistic? So we use percentiles to decide this. So she made adjustments to future fire weather by changing the amount of dryness associated with a 97th percentile fuel moisture condition, or the temperature associated with the 97th percentile temperature based on future projected future climate scenarios, and then simulated fire behavior, and asked whether across a range of different treatments, from an untreated dense forest to a fully restored, quite open forest, which makes more difference, the fire weather or the presence of the fuels? And what she found in the upper right, you see all that red and orange and whatnot, that's crown fire activity on this stand in the situation with the least amount of thinning. And as you go down the right-hand column, it gets lighter and lighter. This is showing the effect of fuel treatments even under these climate change shifted fire weather conditions. This is a quick snapshot of work by Will Flatley, who linked climate FVS to get an idea of future species responses with the Landis model. And Landis is a model that begins to look at landscape patterns of forest stands, of species composition, species movement, and the dynamics of a fire regime. By doing this, he worked on the Kaibab Plateau. This graphic is way too complicated to explain, so I'm not going to try. But what it is showing is several hundred years, about 400 years of change on the Kaibab Plateau. And the conclusion here is that climate change in this period of a few centuries is projected, if the model works well, to produce a compositional change equal to a transition of 1 or 2 vegetation zones. What that means is that where pinon juniper grows today would move up not only to the ponderosa pine, but to where the mixed conifer is currently found. And that disturbance helps facilitate and make this transition faster. Our current work involves applying some of these tools in looking at managed forests on Native American lands on the Mescalero Apache Reservation and the Navajo Nation, in order to try to meet some of the objectives shown here. And if you find this interesting, there's a talk and 2 posters on this topic by the folks mentioned here, Alethea Lima Whitehair and Tyler Mokta, here at the conference. Okay, I want to talk briefly about looking to the south. Many people here, people who work in the Southwest and the West in general, have become aware through a really rich literature and the contribution of many colleagues that there are very fascinating examples in northern Mexico of forests similar to those in the southwestern United States, but different in terms of their recent management history, their land use history. Many places that have continued to burn up to the present, like shown in the graphic there at the top, very high fire frequencies right up through the 20th century, in sync with modern climate, in sync with modern CO2 levels, so places that can be extremely useful to study. So that's one good reason to look south, but that's not the reason I'm bringing up with you right now. Let's look north for a second. Here is a graph of the current distribution of white bark pine and its projected future distribution by about the end of this century. So it goes from about halfway up British Columbia to the northern boundary of British Columbia. Our colleagues in British Columbia are taking advantage of these kinds of predictions by installing an experiment to look at the prospects for at least learning about movement of this species through assisted migration or through planting further to the north. So from a range of southern seed sources, they are planting common gardens to the north in order to learn about this. There is a similar setup. There are many similar setups around the world and around the United States. One based out of Northern Arizona University is the Southwest Experimental Garden Array, where a number of colleagues are looking at tree species and other species and community studies with fungal communities across this kind of a gradient to begin to assess how species may change. One place that we should be looking and thinking about species is to the south, to the southern border of Arizona and New Mexico, where the two species shown here come into the U.S. currently, and then much farther south into their distribution in northern Mexico, where they are found more abundantly, and where they have unique properties like the ability to sprout, in the case of Chihuahua pine on the bottom. Okay, so to wrap up, it's really hard to try to draw implications about climate change, about models, about species migration, about changes in fire behavior, all that kind of thing, from so many different topics, and this is only beginning to touch on the diversity of topics associated with climate change. But I think that one of the things that is really important to try to take home is that management does make a difference. In that quote that Kip presented from the fire manager in Montana, I think it was, he said, we're between a rock and a hard place because of these reasons. And he said something like, except for climate change, it's this social constraint and these decisions that are the problem. Well, climate change puts us even more between a rock and a hard place. And some of the relatively more optimistic predictions here, some of the moderate climate change scenarios, those may not prove to be what comes to pass. But in the event that we do have a future in which native species can survive in something similar to their ranges, even if shifted uphill or northwards, then management does make a difference. And the fire regime should be moving with the species as we go into the future. I wanted to close with the last big picture comment that we need to try to use all of these tools and bring lots of perspectives together, using all kinds of different models based on different assumptions, different approaches, historical and paleoecological data, and field experiments to look at the responses of species. And for us in the southwestern U.S., I feel like it's critical for us to work with Mexican scientists and managers to try to learn about species and try to assist their conservation and their migration in ways that are beneficial to both countries. Trying to deal with these interactions of climate and vegetation and disturbance is really challenging, but ultimately it is the challenge that awaits us. It's what we have to do in order to try to adapt to the climate of the world that we are living in this century. Thank you very much.